Welcome to Automating CI/CD and Testing Best Practices for ArcGIS Map SDK projects. As we sort of talked about pre-session, we're going to mainly be focused on JavaScript workflows. I think most often a lot of these workflows, especially in the testing realm, Java, .NET, et cetera, are more well-known and approachable. And then JavaScript had lagged along and has really come up to speed over the last few years here. So it feels much more like maybe a language that we're used to doing unit testing in for those things. And we'll cover those in some detail here. I'm Randy Jones. I work in Esri Professional Services out of our Washington, D.C. office. I've been with Esri 19 years. So I've seen a lot of change in that time in our technology and a lot of change in development practices over that time. So we'll share some of those things with you today. Presenting with me today is Michael Dandini.
Yep, my name is Michael Dandini, also out of the DC office at Esri. I've been here 14 years, working on a lot of the same projects as Randy and doing a lot of the same kind of practices and stuff, and just I think one thing we've seen a lot of changes and stuff too, and so we kind of want to show you kind of what we've been up to or what we do to kind of deploy applications to our customers as we go forward.
Yeah, so Mike and I work on a lot of big enterprise projects, which becomes important for CI/CD processes. So today what we're going to go through is we're going to start with the testing aspect and we're going to end with CI/CD pipelines. For those who may not be familiar, we're going to talk about types of testing, how those are achieved, and what's the best bang for your buck. We're going to talk about automation of those. We're going to talk about looking at code coverages, what does that mean in relation to our tests. We're going to talk about some specific testing concepts and how to achieve them. We'll have a demo of all of that, and then we'll get into CI/CD pipelines, which has to go hand in hand with talking about source control, talking about building, talking about testing. So we'll wrap up all of those things. And what we'll do there with the CI/CD is we'll go through an example using Azure DevOps today to show that concept. But we'll talk about other options and what might be most applicable to you as you in your environment and your projects. So I'll hand it over to Mike to talk about testing.
All right. Thank you, Randy. So let's start off with what's probably an obvious question that we should all know, but it's worth knowing what the answer is for us, which is, why should we test? Anybody? Bugs, we've heard. Sleeping? Sleep at night. So you can sleep at night, that's right, too. It's a great reason. So let's go into some other issues, which is, first of all, testing is great because if you detect your issues early, it's going to reduce your cost, and it's going to reduce the amount of issues you deliver on site. So if you don't find your bugs, your customers probably will, so it's best to find them as early as you can. And when you do that, you'll increase your customer confidence, all right? So your customers will have, your code will be more stable, version to version. Your customers will be rely more on your code. They'll be more confident when they use your code that it actually works. And finally, it just promotes good development practices. If you have code that is well tested and is easy to test, that's usually good, clear, correct code that is easy to maintain, both for you and for anybody else who inherits your code after you've moved on to another project. So before we get to talking about testing, let's think about how we want to prepare for our tests. So the first thing you really should think about is you need to get or create test data that matches the reality of how your users use your application. This is often the hardest part because you have to really understand your users, and if you're working on a project that hasn't been created yet, how do you know what the reality is of how your users are going to interact with it yet? very tricky. If you're working on an existing project, you may want to think about obfuscating your real data. That might not be possible given your situation, but it really does pay dividends to really look at your test data and make that and lock that down so it's accurate. You want to have a plan for this testing. Some people think they have a plan, but really they're just clicking around and entering stuff in the box or in the boxes. What you really want is a repeatable test plan that you do the same way every time so that you are aware of when issues come up and if things change between versions of your software, you can find them easily. Also, you need to know and define how you set up and tear down your testing environment. It should be stable and consistent for every test. A lot of times, if you don't do this, you run the same test twice and it will come back different each time. And so if you know how to set it up and tear it down, that really helps make your testing stable and consistent. So when we think about the types of testing we do, you can look around and there's a couple different versions, but a lot of people talk about what they call a test pyramid. Now, this is kind of a simplification of some of the concepts we talk about in the types of testing. Some people have more issues or more types of testing in it, but this is kind of how we see it. So discussing this from the bottom up, at the bottom you have unit testing, which is where we simply test isolated sections of our code. So individual functions, individual classes, things like that. This is often the first thing you do because it's one of the cheapest and fastest tests to implement. Usually it's written by your developers, and it can be written or it can be created early in the development process. Going up the pyramid, next is integration testing, and this is where we test how the components interact with each other. So often what we'll do is we'll mock out or we'll compare and see how systems work with each other, how functions call each other, things like that. In this system, often if we have to go to an outside system, like a third-party service or a database, we'll simply mock or fake out that interaction just to help facilitate our testing. And finally, at the top of the pyramid, that's where we get into end-to-end testing, and that's where we look at the system as a whole. That may sound very similar to integration testing, but in this case with end-to-end, we're not trying to mock anything. We actually have our third-party systems up. We use the same services we would. It's as close to production as we can possibly get it, and that's where we do our end-to-end testing. Now, one of the things about thinking of this pyramid is, as you go up the pyramid, the cost to implement and run your tests gets higher in terms of creating the tests and also how fast and easy they are to run and execute the tests. And again, also the time to develop those tests gets longer. So writing a unit test is not, it's pretty quick. You can do it as part of your developing. But when you start getting to end-to-end tests, you start having to coordinate teams, start coordinating across different people, or different people and different components to do your testing. So that starts increasing the time it takes to develop. Now, there are other types of testing, such as performance testing, user acceptance, and what some people call exploratory testing, where you're trying to deliberately test the bounds of your system and what it can handle. But we recommend starting with these three because they generally give you the most bang for your buck, and they're generally the ones that most developers take part in the most. So we'll start at the bottom of the pyramid and start talking about some best practices for writing unit tests. Again, this is where we're simply looking at small components or small functions individually in our code. And there you really want to look at isolating the functionality as much as you possibly can. Try to look at only testing one function in your code at a time. This is also a great time to start looking at trying to break that piece of functionality as you can. So this is where you want to start looking at running in, or doing error testing, testing out exceptions. You may want to look at do stuff what's called fuzzing, which is where you simply try to deliberately give weird values to your data. For example, if your code's expecting a string of text, give it a bunch of numbers, see what happens. Of course, some places might some code may do typecasting on this thing too, but again, that's something you should check out. For when you want to start planning for this kind of unit testing, you really should think about how you need to set up each function and class for testing. What does the environment for that code need to look like? How do we need to set up? What does it rely on? Things like that. Another thing you should think about too is you only want to test your code for this unit testing. You don't want to be testing the ArcGIS Maps SDK. You don't want to be testing third-party libraries for this code. What you'll need to do for that is you'll need to perform stubbing, mocking, or faking anything outside of the part under test in order to force your code to go down certain paths within the repository. Something to also keep in mind during this part of testing is if you're finding it hard to test some of your functionality, that's usually a sign that that code's going to become hard to maintain going down the road. So if it's hard to test, refactor it. Believe it or not, as part of the demonstration program I'm going to show you later, if you look at the GitHub code, you'll see I myself did this. And what I do, I simply refactored out some of those functions into another class so that we could go and run the tests easier too. As a result of that, it kind of separated out the, it separated out the responsibilities into two different classes, and it's much cleaner and more easier to maintain that code now. Finally, you really want to make your unit testing as part of the development routine. One thing I'll do often is while I'm updating code, I can run Jest's watch functionality, which basically just constantly runs the unit tests for any piece of code that gets changed, or any class that gets changed or test that gets changed. And I can see immediately if something breaks. If I make a change and it breaks the test, I know I either have to update the test, which is probably what a lot of people do, but also it's a sign that maybe I'm not thinking about this update correctly, and I need to rethink and redesign how I'm doing the test. Moving on to integration testing. Again, this kind of fits in between our end-to-end and unit testing. Again, just to reiterate, when we think about end-to-end testing, we're looking at that system as a whole, from the user clicking the mouse to a record getting created in the database and then being brought back up. With this integration testing, we're looking at the interactions between these components. For example, we may have a database interface that simply, any piece of data we get, we write to a database or something like that too. And we may have a web form that when a user enters in some data, it sends it back to that database interface. What we're looking at with what we're looking at with unit testing is we're just looking at that database interface by itself, the functions within it, same thing with the web form. For integration testing, we want to see what happens when our web form component calls our database component and compare how they interact with each other. And finally, when we actually start writing stuff to the database through the database interface and the web form, that's when we get into end-to-end testing. And I know I may have mentioned this earlier, but I want to repeat that just so that we get those definitions clear. So the hardest thing with the integration testing environment is you want to align this test environment with your production as close as you can. And that's part of that planning we talked about too. You need to think about how you're going to set up these interactions between, or set up the testing environment such that you can accurately test the interaction between these components. So you may need to consider starting up or scripting the startup of the environment and tear down so that you can have a consistent environment every time you run these integration tests. Also for this testing, focus on your critical paths, okay? Unit testing is great for checking the extremes of your code, the edge cases where things go wrong. For example, if the database goes down or things like that. For your integration testing, you want to talk about the most common uses for your code. There are some failure scenarios worth testing. For example, if you're coding up a logon system, it's worth adding a integration test in to see how the system reacts when a user fails logon. But for extreme cases where things are not missing, servers are missing, things like that, best to save that for unit testing. And again, I know I mentioned this earlier, but testing data should be as close to the reality of how your users actually use the application as possible. It's hard to do, but this just makes testing a lot more effective and gonna make maintaining your code a lot easier if you take this step and go through it. Finally, we'll get to end-to-end testing. Again, this is where we look at the whole system. You want to think about the end use of this application here too, okay? That's how your users will actually use the system daily. You may have to work with your customer to help come up with use cases and scenarios for running this test. A lot of times this end-to-end testing stuff is also run by people, and the test itself, some of it may be scripted, but a lot of it is also just done through a Word document with step-by-step instructions. Again, at this point here too, we're not trying to break anything in our applications. That's better left for both the unit and the integration testing. But what we're trying to do here is just make sure that the system works as a whole. So when we start trying to plan these tests, it's very important that you can repeat them each time. That means making the steps clear. Now, that doesn't mean, okay, click on the map, enter some text and observation, click submit. As you can see in this screenshot. You need to say, click on the map, type in, this is my observation, into observation, then click on submit. It needs to be very detailed, so you can repeat this each time. And again, plan how you're going to set up and tear down this test. You really want this environment to be as consistent as you possibly can so that if anything goes wrong, you know it's not because something was wrong in your environment, it's because something went wrong with the code and in your test. Now that sounds like a lot of stuff, so we probably want to think about some ways to automate this test execution. Right? Automating test execution is great because again, it makes sure that we can repeat these tests, and it also involves the developers early in the testing process so that they are ingraining this idea of testing their code frequently as they create the product. One thing to keep in mind too is that since the test should be repeatable, that means you should be able to run the test twice in a row and get the same results. So I have seen tests where it depended on the time of day if you ran it, if it was going to pass or not. That's not ideal. You want to be able to run it whenever or wherever you need to run this test and get the results, and make sure the results are the same. Another thing to point out is that just because you automate your test execution, it's not a replacement for human-led QA testing, okay? You still need somebody in the loop to kind of go through a test plan, preferably an end-to-end one, and write out all, and check that all, and do testing of the final testing of the application. QA testing is great for user sell-off testing, where your customer is sitting there next to you and is showing you, and you're clicking by the customer, showing them each part of the code going through it, meeting their requirements. And it's also good for exploratory testing, where you do simple things like we talked earlier about having a field for text. Well, then you just type in some numbers and submit it and see what the system does. You know, it really, automated tests will complement this manual testing, and so you can really get a good solid program settled down. When you do want to automate your testing, it's best to start at the bottom of that pyramid with unit testing and automate that first and then go up. Because again, As you go up that pyramid, it's going to cost more money and more time to implement those tests and run them. And finally, please maintain your tests, these automated tests too. It's going to change over time as your code base time. There's nothing worse than when you're trying to test something and all of a sudden another test somewhere else fails. And now the question is, did my change fix that? Or did my change break that code? Or did something else break that code? And sometimes you find out it has nothing to do with you. That test has been failing for months. And now what do you do? Is it because of what you did, or do you have to go fix it? I want to make a quick comment here too about code coverage. For those of you who don't know, code coverage is basically a way of measuring how much of the source code is covered by your unit tests. Again, from the screenshot here, you can see you can get reports. It tells you how much your code is covered. One thing to keep in mind is that this isn't necessarily a measurement of your code quality. You can have really well-covered code, but it could still not meet your customer's requirements, and it could still be failing when you go to production. Okay? What you really should be looking at with your code coverage is what you haven't tested yet, what isn't covered by your unit tests. First thing to ask, is my critical path fully covered? Okay? Am I covering most of the important functions of my code with the unit tests? If you see edge cases that aren't covered, that's a point for discussion. Should we add a unit test for this? Is this something that's going to happen a lot? Again, a user failing login is something that's going to happen a lot, so you probably want to cover that with a unit test. Something like a server being deleted or any other kind of random edge case might not be that important. So save your time and go work for something, and go spend time developing on something else. And something else to keep in mind too is that as you try to increase your code coverage, you're going to start experiencing diminishing returns on results. It generally takes as much time to get from 0 to 70% code coverage as it does to get from 70 to 90% code coverage. And it takes the same amount of time to get from 90 to 95% code coverage. So there's not really a magic number for this, but I did do some research, and we looked around a bit. And Atlassian, the folks who make Jira, the issue tracking software, they say if you're getting about 80% code coverage, that's pretty good. Google, they say 60% is acceptable code coverage, 70% is pretty good code coverage, and finally, if you can do about 90%, that's exceptional code coverage. So there's no magic numbers, but there's some magic numbers for you if you want to really get into it. One last thing I want to talk about too is I mentioned faking, stubbing, and mocking earlier in the presentation. These are just ways to simulate behavior of your application to facilitate your testing, okay? For example, you can force your code down certain paths to see how it handles certain situations and environments. Let's define those terms really quick. When we talk about a fake, that's just a lightweight implementation that's going to streamline your setup and teardown. So it can be a lightweight database interface class that maybe it does call the database, but it doesn't do some of the validation or other things. Or it calls a very simple database or a different database. When we talk about a stub, that's an implementation that has canned answers to your calls. By that I mean is that instead of actually calling a database, we just give it what the database would respond with. That comes up a lot when we need to do exception testing. We can make a stub that kind of forcefully throws an exception at us. And finally, we can talk about a mock, which is kind of a stub, but it also monitors how it's called. So the advantage of that is we can see if you can think about a class that where we're passing data between two components. With a mock, we can pass over parameters, or we can check the parameters that are being passed between these two components and verify that they are, they are what we expect when we start passing data between components. While this sounds pretty powerful, you need to keep in mind that you can go too far with this. It is perfectly possible to create fakes and stubs that mar actual test failures and that prevent you from actually finding real bugs in your code. So the best way to combat this is to combine it with integration testing. So one thing I like to do is to have a main test that does a minimal amount of mocking. For example, I'll write a main test for a public function that calls the private ones. For the big test, I won't mock out any of the private functions. I'll make sure the public function calls all of the private functions, and I'll only mock out third-party calls when it basically has to leave the class. When it comes time for edge and error case testing, exceptions and things like that, then I will mock out those private calls to private functions so that I can force my main function to go down certain paths within the code. So it's probably best now to simply bring up an application to kind of demonstrate some of these topics we've talked about. Now, let me go ahead. Oops, sorry. There we go. I'll simply duplicate my. Okay. So I've created a simple demo application right now that goes through and shows some of these concepts. It's available on GitHub under the Esri Dev Events repository. It's public, so you should have access to this. And it's simply called Testing Best Practices for ArcGIS Maps SDK Projects. It's a simple project. Here it is right here. And all it is a simple web page. You click on the map, creates a little X. You can see the observation here. You type in something. Hit submit. And then it simply creates a circle on the map. If you click on that circle, it simply brings up a simple pop-up window. Let's talk about some of the concepts in the code and for this class. So I simply blocked out some things here to show you some concepts. So first thing I want to talk about is blocking out third-party requests in here. So my API, this fetch data class, goes through and simply sends data back to a backend endpoint to submit out to both load the data and save these observations to the map. For this, I used a library called just fetch mock to kind of mock the calls to the fetch function in JavaScript. With this, I can simply just make a mock response saying I want fetch to return a specific value, and then I can check what fetch did to call out or to see what it was called with. As you can see, I can check all the parameters that the fetch function was called with to make sure that I'm passing the expected values to this third-party application. The other thing I want to point out is this map container, which is basically a React component that simply just holds the map and controls interactions with the map. Here in the map container test, you'll see I mocked out all the ArcGIS Map SDK components so that instead of testing the ArcGIS SDK, I'm only checking my code and seeing how that interacts with the map. Now, in practice, what this looks like here is, if I bring up the PowerShell here too, what we're looking at here is the just watch functionality. This is basically running the unit tests constantly as I make updates to the code. So if I change fetch data, map container, or app, this will rerun all the tests over that piece of code. So I can also just manually go ahead and rerun it by typing A, and this will go ahead and run through everything. You can see it passes all the tests. Another option is there are libraries, for example, one good example is called Selenium, that will actually mimic user behavior as we run the test. So I wrote if you go to the project, you'll see there's a Selenium test script, which I can run with Node. As I go ahead and run this, this will actually open up a web browser, open up the map. It will actually click on the map, eventually. There we go. Enter an observation, submit it, bring up the pop-up window so I can verify that the code is still working. This can be a little tricky because you do have to put in weights for elements and things to load into the map. But again, this is all something that stuff that you can script so that it's running all the time, or say put inside a CI/CD pipeline, which Randy will now talk about now. And if I can get over to the, worked.
Okay, so that we can try to tailor the back half of this presentation, how many people do we have that are single developer shops? Like you are developing on projects by yourself? Okay, not too many. And how many are on like larger teams? This should be the other half of the room, right? Okay, good. And then how many people are currently using some CI/CD? Okay, excellent. All right, so some of this here we'll go through a little more quickly since we have a little more experienced crowd, it seems like. So before we get into CI/CD and understanding all the benefits that it gives us, I quickly want to go through a scenario here that developers usually start with before they get into CI/CD. So we have a developer here doing a great job committing code into the repository. When we start to talk about deploying to operations, they're copying code somewhere, either a web server, maybe into some sort of object store that's hosting their static code application. During this phase, they have to make additional configuration changes. Maybe they didn't get something right the first time. And then they continue to have to modify that code because they're either finding bugs or errors with the configuration. And this is manual process every time. And then as the team grows, this becomes more and more problematic. There's more cooks in the kitchen. We're very prone to errors as humans, right? And so it's a good thing if we can think about starting to automate that. Now, as our projects grow, either in importance or in complexity, we usually add things in the middle of our deployment pipelines, right? We have a similar path to get to operations, except that we usually add a test environment in the middle. This is where our QA goes on, our quality assurance testing goes on, or our end-to-end testing that Mike talked about earlier. This is where we're trying to ensure everything possible to make sure that going to operations is going to be successful, except that we still have these manual steps, these human error-prone steps along the way to get us there. Okay, so let's explore what CI/CD is, how it helps us, and how we get into a real-world example here. So CI/CD, we're going to use tools and automation during our code integration, development, and deployment, right, to increase our deliveries and our code quality and decreasing the time that we spend doing that testing, that staging, that deployment of code. I mean, developers don't want to do all these activities all the time, right? Like we suffer through to get our art, if you will, out for the world, right? But we want to do what we love best. We want to develop. So the flow that we have to think through for CI/CD pipelines is very similar to what you might think of as a software design lifecycle, right? We are looking at our goals to increase the code quality on the base and delivery. And we need to think about what we're doing during this flow to achieve that. Today, we're really going to be focusing on these aspects of the building, testing, releasing, and deploying of our applications. But once our applications are deployed into operations, we're constantly monitoring, planning for the next phase, and starting to code our next features again. And we want this pipeline to then be as smooth as possible. So when I asked earlier about how many people are using CI/CD in some way, there's a lot of layers to that question. You could be using it in a simple way, or you could be using it as a full pipeline to get to production. And many of these steps mean different things to people and are going to be dependent on your application itself. So what starts always with a good CI/CD pipeline is your source control. There are going to be many variations in your CI/CD process, and it's going to, how the CI/CD pipeline fully plays out is going to depend on your application's complexity, the architecture that it's in, what you're developing it in. Is it a web application? Is it a desktop application? What are the toolings that are going to be available and necessary to complete your pipeline? So we're starting with good source control. Our developer is putting her code in and doing a good job. And then we begin to see what our flow looks like. When we do this, we are setting up ourselves for success, thinking through the steps that are necessary to begin a repeatable process to get our code into production. Within these 4 steps, we're going to look at each one and think about what this could look like. Your pipeline might look different than this. I don't want you to think about this pipeline in this example as the end-all be-all and the correct way to do it. I think there are some fundamental things that we're going to show here and talk about, but at the end of the day, you need to be flexible enough and recognize what is right for your application. So when we talk about the build phase of our application, right, we had a bunch of people who indicated that they were not JavaScript developers, right? So if we are in a .NET or a Java world, we understand what compiling and building an application means in a way that's different than the JavaScript world. The JavaScript world, that's a much newer concept because it's not one that is driven out of the language necessities. So as a scripting language, as an interpreted language, we don't have to do that with JavaScript. But what we've learned over time and what frameworks often help us with now, because they have some opinionated build step to compile our JavaScript, for instance, using Webpack or Rollup. There's some other options as well, that's going to combine and obfuscate and help us get the most out of our application by providing optimizations for the browsers. We might be transpiling code to make it work in older browsers, although that is thankfully becoming less necessary each year. And in this case, we're going to start running tests. This is a place for us to run our QA tests, possibly our integration tests, depending on what our application looks like and what our components look like. And this is a place where we can start making some choices. If our tests fail, do we want to stop the whole pipeline and go back and fix it? That certainly is going to be promoted as a best practice, but there may be reasons that you don't want to do that. So next, we're thinking about our test phase. This is where we're deploying the test into that QA environment. We have the app deployed, ready for use. We can run our end-to-end testing. We're testing our deployment scripts as well. I think this is an underutilized thought process during the CI/CD phase, getting all the environment variables correct for some environment besides my development box. And this will help me as we then go to deploy to production to ensure that we have the best possible chance of a deployment succeeding and being immediately ready for our users. So this is also the phase where we might bring in our release manager, or we might call them a tester, where they're going to also look at that testing that Mike talked about. We might look at additional fuzzing. We might ask the tester to seek usage in the app that we wouldn't have thought of during our planning phases and how we planned out our code creation. When we get to our release phase, this is where maybe we are tagging our code in Git. We are capturing the archive of the code that we are saying is going to be the next release moving into the production. We might stash this in an object store, or we might be uploading it into our source control. Depending on the features of the source control that we're using, they have the ability to create releases, upload it, have it tie into one of our Git commits as well. And then when we finally get to our official deployment phase and our release, we're putting it out into the world. We should have had our deployment scripts tested at this point. We should have high confidence, and we're looking at validation. So this is where we're rerunning our end-to-end tests to ensure that what is in operations is what we expect to be there. So when we look at all these phases of our pipeline, there's lots of options available to us to run these. If you're in an on-premise situation where you want to run it either within your own environment, locally, maybe you need to be behind a firewall, maybe you're in a disconnected environment without access to the internet. You have some options like Jenkins, Travis CI, Circle CI, are all options that are available for that type of deployment. If you're deploying into a cloud environment, you now have some different options available to you. You might be looking at Azure DevOps. You might be looking at AWS Code Deploy. Or you might be looking at solutions with some of your tools have built in. GitLab has, for instance, a CI/CD process built into its enterprise on-premise deployments, as does GitHub, both in on-site as well as the enterprise deployment of it. That all can be utilized to start building this pipeline. Now, pipelines don't always have to just look like a continuous process, right? Quite often, what we do is we have pauses. We have places in our pipeline where we're taking a step back and assessing what our application is. This may be, as we're going to show today, I'm going to show a pipeline that matches what we're seeing on the screen. We have the first phases where we're going to get to a QA deployment of our pipeline, where we can then go run our tests against. And then when we're ready and we merge our code in to our main branch or our release branch, then we're going to get that set up there. So let's look at what this looks like for us. So I have a simple React application, and this does nothing fancy. We have a 3D scene that we're going to show. The application is really simple. So right now, you can see down here in my terminal, I've actually started the application already, and we have it running here. We have a nice little portal item that we've pulled in over Paris. We have some 3D buildings that we're seeing. We have a few pieces of functionality here. We can do some measurement of distance and area, and we can rotate, zoom in and out, etc. So nothing fancy about the application. We're running it local. If we were to go over here and look at the package.json, we see some things similar to what Mike told us about. We have a test script that we can have running and watching our tests as we're developing. All that, you can see we have a test that is a little different flavor that's intended to be run within the continuous integration software. And we'll talk about this in a little bit, but you'll see here we have a reporter here, and what this is going to do is instead of that on-screen output, we're going to dump it out so that we can preserve and understand what our tests look like as we go through each build of our software. So we'll hop over here into Azure DevOps. If you don't have a solution, Azure DevOps is a nice one. It has a bunch of features with it, with boards for issue tracking, repositories for our code, obviously pipelines, because that's where we're here talking about today, and then those artifacts, those things that we talked about archiving off. So when we look at here, here's the repo tab of our Azure DevOps project. You can just see this is exactly what we were looking at before. Just Git repositories, nothing fancy. It's no different than if we were in GitHub on this case. And we've already set this up in a few ways. You'll see some files here that probably look confusing at the moment, but we'll get into those here in just a second. So since we're in Azure DevOps, we're going to use Azure to deploy this. In this case, since it's a static application, it makes it really easy. We don't need any specific sort of server. We can just throw it in an object store. Obviously, if our application was more complex, if it needed to be deployed into a certain environment, if it's a .NET web application, if it's a Java application, we could do those in a different way as well. So in here, we can just choose a static web application. I have a resource group already set up for this demo. We can give our static web application a name. In this case, we can just go with the free because where we are doing. We can see in our deployment details, we have a couple different options. Since we're living in Azure DevOps today, it makes it real easy to check that, and we can just go through and check our project repository and even the branch of our code that we want to do. So we're going to show here 2 branches in our code. If you're interested in branching strategies for your code, if you're not familiar with that, I'm happy to talk with you. We've also done presentations in the enterprise JavaScript in past years at Dev Summit. The videos are online and talk about branching strategies that you can use within your code for that dev and release process. In this case, because we're using the static web application, we also have the ability to set up a number of specific build scenarios here. If you're using Vue or Svelte or another framework, you can certainly choose that, and it helps ease it. We're just using the default build directory out of our React application, so we'll leave that as it is. So what this does when we do review and create is this creates a YAML file over in our application. So here today we have 2. So this one here will be our dev branch, and this will be our master branch. So when we look at these, we're going to see a couple things here. So this is YAML. I don't know if everybody's familiar with YAML, but it's used a lot in data representation. It's very popular in our pipelines, both on-premise things like Jenkins, like we talked about earlier, support YAML files. Ansible, if you're doing any sort of infrastructure automation, we'll use YAML as well. So it's a popular format. You can see it's got spacing and tabbing similar to Python, if you're familiar with that. So up here at the top, we're talking about how we're going to trigger this, this pipeline. And then we get into the steps, the jobs that is going to happen within it. We see that we're doing some setup for our static application. What's nice here is we could have written this all by hand. Azure is helping us out a little bit through that static web app creation process. The steps are pretty simple in this case, because this is our operational deployment. In this case, we're still going to be using Git. We're not going to deploy it from a tagged resource at this stage, but we're just going to use anything that gets pushed to the main branch, we're going to deploy it. That's how we're initiating in this pipeline that it's ready for operations. You can see here in this Azure Static Web App class, it's helping us since we set it up, being that React application, it's got a bunch of helpers in there for us. We could go and do steps step by step. We could set up a node task. We could do npm install, we could do npm run build, and all those steps separately. This is a wrapper task that helps us do all of those things. So when we look at it in the pipeline format, we can see that this is the one running on our main branch. We can see that I've run this a few different times. When we click in here, we get information about the build, how long it took, when it was. We can get into exactly the command line on the build and what it was. And we can see each of the steps here that it was. We checked out the code. We ran that helper task that was going on. You can see here there's a lot going on. It does the build React. It does the React build, and then ultimately it comes out and it deploys our application. That application is here. So it's now live in our static hosting. And thankfully, it looks just like our dev. Now, I've created a second pipeline here that looks slightly different. And we'll come in here and we'll look at the YAML file for this one. And we'll see that I've added some additional tasks. I need node for this, so we're going to add the use node task. We're going to tell it then to run a script, npm install. Then we're going to run another script where it's running our tests. Finally, different from our operational deployment, is we're going to publish the test results. So this is now going to capture the test results within Azure DevOps so that we can come back and see the results over time. We can see, are tests increasing in failures? Are they decreasing in failures? Are we doing a good job and succeeding every time? And one other thing here. There are lots and lots of tasks available within Azure DevOps. It does have a lot of features available and tasks available. You can go look at the documentation. There's lots of tasks for building, testing, deploying, et cetera, and we'll help you through lots of that process. You can also come back and look at examples that they have about different languages and types that you are going to be looking to build and deploy within there, right? So we have Java examples, Android examples, .NET, Python, et cetera. So Go, Ruby. So lots of options for lots of different project types. So if we come into the last run of this code, similarly, we see all of our job steps, and we can go in and we can see all of the different output that is from those tests. We can come in here and we can see in our test CI, we have two things going on here. I'm capturing and going to show you today the testing part of this. And we can see here that both of our test files passed in here and are highlighted. But we can also see down here at the bottom, it actually did some code coverage as well, which can also be imported into DevOps. So when we come back to our job and our last run, we can see up here we have tests that were run. In this case, we had test pass. And we can come here and we can examine the tests. We see that there were 8 tests run. We passed them all. We didn't have any failures. And in this case, like I said, we didn't have code coverage get imported at the same time. So we can start to see how our tests grow or progress over time. With our test plans and in our run. So we can see here that the tests were completed. We can come in here and get the details similar to what we were seeing on the other screen. Okay, So we have now successfully gone through our entire pipeline. We started sort of with the end and worked backwards. So this is now our test application ready for our tester, or QA. And we've now completed that pipeline in a two-part process, like we saw laid out in our slides and in how we were expecting to go today. So as we wrap up here, we will have just a couple minutes here for some questions. But what Mike and I are really hoping that you take away from today is that you understand how to get the most bang for your buck in testing your project, and that you are beginning to have an idea of how to take a CI/CD pipeline and apply it to your own projects to both save you time, save you money, and let you get to be doing what you love to do best, which is develop. So thank you everybody for attending today. Mike and I will be up here for questions. We'll be outside at the professional service flag for questions if you have them there. And then the rest of the week we are at the island that's doing code reviews. So that's back in this corner of the hall. So you can come and find us there as well. We're happy to sit down and work through with you any questions you might have. Do we have any questions here for the last couple of minutes here from the audience? Maybe we want to answer for the group. You can always come up here at the end as well. Yeah.
Would you create a stub for like making calls to the Esri services, or would you actually just make the calls?
So the question is, would you make a stub or would you make the actual calls to Esri services when you're doing your testing? You want to?
Yeah, so for like a unit test where I just want to focus on my code, I would stub out that functionality to the Esri services so that I'm not testing the Esri services, I'm just setting my own code. When we start getting into something like an end-to-end test where we want to test the whole functionality of a system, then I wouldn't stub out that functionality. I would make sure that we're calling the Esri systems and we're getting the data back that we wanted.
Any other questions?
In your previous slides, you had the coverage.
Mm-hmm.
You had this screenshot.
Mm-hmm.
How do you create that? How much is covered by the test?
So the question is that when we talk, in its previous slide, we had we had a report that generated the code coverage report. The answer for that is many tools have that built in. I've seen where they'll output just some text on the screen, which you may have seen in Randy's CI/CD tools. But I've also seen to where they'll actually, if you specify as one of the parameters as part of the code coverage generator, it will output an HTML file, and that you can then serve that up. There's several different ways to do it. It depends on which tool you're using and how you want generated. Yeah, that one right there. Yeah.
Yeah, so in this example, in the test that was run in my sample application here, just running test React with the reporter set, that also dumps out the code coverage. So we can come into the same project here, looking at coverage, and we can find in here that index that shows that.
Thank you so much.
You're welcome.
Yep. Last one, and then everybody can come up if they have more.
Yeah, sure. So the question would be like, what would be the best strategy if you're heading over with a project that has to be implement any unit test or other integration test? In this situation, what would be the best strategy or best practice?
So the question is, if you're handed a project with no testing, what do you do? I think in the real world, Mike and I probably share the experience. As soon as you touch something, you start adding tests to it. I think the reality is, I mean, there's a reality of business, right? Like, it doesn't make sense to go back and spend a bunch of money to write a bunch of tests that for something is already in production. maybe not. But as you touch things, I encourage you to add unit tests at that time.
Yeah,
and
it's
do
a perfect
that.
time to do
There's
it.
certainly a balance between like what we say is ideal from a dev and testing perspective, right, and the realities of business and us being able to pay the bills at the end of the day. So thank you all for coming. Again, we will be outside at Meet the Teams. We'll be in the exhibit hall all the rest of the week. And feel free to come up and ask questions as we close out here. Thank you, everybody.
Thank you.